Hello everyone, I am Pankaj Kumar Swarnakar, Assistant Professor, Chhattisgarh Swami Vivekanand Technical University, Bhilai. Welcome you all to the course Essential of Surveying, Application and Techniques. Let's begin with our first lecture of this course. This lecture will cover the following key points. First point, introduction. Second, basic principles of surveying. Third, classification of surveying. Fourth, nature of survey work. And the last point is units of measurements. So, what is surveying? Surveying is art of determining the relative position of the points on, above or beneath the surface of the earth by means of direct or indirect measurements of distance, direction and elevation. You may find this definition complicated at this stage. So, let us discuss each term of definition one by one. The first point in this introduction is relative position of point. Means our aim is to determine position of the points in relative sense. We want to know the position of point with respect to some points. Some points means some reference points whose locations are already known. For better understanding, I will give a simple example. If we say a point has coordinates x, y. These coordinates are obtained with respect to an origin whose location is already fixed and the coordinates of the origin are known. You know what is coordinates of the origin in the coordinate system? It is 0, 0. So, when we are having some points whose locations are fixed initially and coordinates are known, then only we can proceed for establishing new points. Similarly, in surveying, position of some reference points are fixed and the location of the rest of the points are calculated with respect to them. Reference points are also known as datum or benchmark. Now, we will discuss second term of the definition. So, we have discussed that surveying is art of determining relative position of points on, above or beneath the surface of the earth. Let us try to understand this point on, above or beneath the surface of the earth. See the point of interest. What is point of interest? Point of interest means the point whose location is required. So, this point of interest may be on the earth surface, it may be above the earth surface or it may be below the earth surface. I will give a simple example. If we understand ground level as a earth surface, so if any building is there, so top of the building will be above the earth surface and the footing of the building will be below the earth surface. Now, another term in the definition is direct and indirect measurement of distance, direction and elevation. Let us discuss first what is direct measurement and what is indirect measurement. As name suggests, when we measure a required quantity directly, it is termed as direct measurement. Conversely, when another quantity is measured and the required quantity is calculated using some relationship between them, then it is termed as indirect measurement. I will give a very simple example for understanding purpose. Suppose I want to calculate length of this room. What can I do? I can directly measure it using a chain or tape. Let us say it comes out to be 3 meters. So, this type of measurement is the example of direct measurement. Now, if I want to calculate the height of the room and I am having some difficulty in measuring directly using a tape, but the length to height ratio of this room is known to me, then what can I do? By measuring the length of the room and using the relationship between length to height, I can calculate height of the room. This is an example of indirect measurement. So, in the surveying, we are supposed to take direct and indirect measurement of distance, direction and elevation. We have discussed about the direct and indirect measurement of distance. What about direction? So direction measurement are also important in surveying. So direction measurement means measurement of the angles. So angles are measured by the angle measuring instrument in surveying. The next term is elevation, distance, direction and elevation. What is elevation? Elevation denotes height at which point is situated with respect to reference point. I will again give a simple example. If the room height is 3 meter, the room in which I am sitting, if the room height is 3 meter, and if I assume the base of this room as datum with an elevation of 0 meter, then can I calculate elevation of the top of the room? Yes, elevation of the top of the room will be elevation of the base plus the height. So 0 meter plus 3 meter, so elevation of the top of the room will be 3 meter. Surveying also includes the art of establishing points by predetermined angular and linear measurement. What is this point? Earlier we were discussing that the point is there somewhere in the ground. We want to calculate the coordinate or the location, means we want to have some angular and linear measurement value for that point. Here the reverse process is also possible, means if we are having angular and linear measurement with us, we can establish the point on the ground. Surveying have many branches. The most important branch of surveying is leveling, which deals with taking measurements in vertical plane. In the vertical plane, most important measurement is elevation of the points. Elevation I have explained earlier. So leveling used to find out elevation of the point with respect to an assumed datum and also to establish new points at a given elevation or given different elevations. We generally see in railway station, when we visit railway station, there is a board in the platform where height above mean sea level are given. I think everyone have seen this. So mean sea level is taken as the reference point and elevation of stations are measured with respect to that. Okay. Now we will discuss about the importance of surveying. Surveying is an important part of many branches like civil engineering, mining engineering and architecture. In civil engineering, it is the first key step of any project. It provides critical information that helps engineers, architects and contractors to design and build safe, efficient and cost-effective projects. The planning and design of all civil engineering projects such as construction of highways, construction of bridges, tunnels, dams are based on surveying data. Moreover, every project of any magnitude is constructed along the lines and points established by surveying. I will give a very simple example. Let us say a building is to be constructed. Then can you tell me what will be the first task which to be performed? The first task will be to give layout where the position of the columns are marked on the ground. After layout only, excavation for footing can be started. Now we will discuss effect of earth geography on surveying. Earth geography plays a major role in surveying as measurements taken in surveying depends on geographical features of earth. Now let us discuss some features of the earth. The earth is an oblate spheroid of revolution. What do you understand by oblate spheroid? Means spherical in shape but not perfectly round. With its length of polar axis, means earth is having length of its polar axis somewhat less than its equatorial axis. You can see in this figure, the polar axis is shorter than equatorial axis by 42.95 kilometers. We must understand some basic terminologies for surveying to understand effect of earth geography. The first and very important terminology is plumb line. So what is plumb line? Plumb line is a line drawn from the earth surface directed toward the center of gravity of the earth. Means it is directed toward the center of the earth. Plumb lines are perpendicular to the earth surface. As you can see in this particular figure, you will have a better understanding. Now, if we take a plane passing through the center of the earth, and in this particular plane, if we place a number of plumb lines, so what will happen? These all plumb lines will intersect the earth surface at various locations. Now, if we join these intersection points, so the circle which is formed by joining these intersection points is known as great circle, and a segment or part of this great circle is referred as level line. I think you can better visualize by this image. Now we will discuss primary divisions of surveying. Primarily, surveying can be divided into two classes. One is plane surveying, second one is geodetic surveying. Because the curvature of the earth plays significant role when we deal with large areas. But generally what happens? We deal with very small portion of the earth. When we go for surveying in a city or in a colony or in a village, that is very small portion of the earth. Therefore, neglecting its curvature in that particular area does not hamper the accuracy of measurement significantly. So, plane surveying is a type of surveying in which mean surface of the earth is considered as a plane and the spheroidal shape is neglected. As discussed earlier, when we visualize complete earth, level lines are curved along the periphery of the earth. But since very small part of the earth is participating in the surveying work, so level lines can be considered straight line, curvature can be neglected. So when level line is a straight line, and we know plumb lines are perpendicular to the level line, so all plumb lines are considered parallel in plane surveying. I think you can see in this particular figure. Now the next type of surveying is geodetic surveying. Geodetic surveying is adopted for work of large magnitude and higher precision. Why? Because it accounts for the spherical shape of the earth's surface. Therefore, level lines are curved and triangles are spherical triangles. Now we will talk about principles of surveying. All surveying methods are based on some fundamental principles which can be summarized in the following points. The first principle is location of a point by measurement from two points of reference. As discussed earlier, in surveying, position of some points are fixed, those points are known as reference point, and location of other points or new points are determined by measurement with respect to them. So the first principle is relative position of points to be surveyed should be determined by measurement from at least two fixed reference point. Means we are supposed to have at least 2 points whose locations, coordinates are known to us. Reference points, as discussed earlier, are also known as datum or benchmark. So you can see in this particular figure, 2 points A and B are shown. Now these A and B are reference point. Now you want to establish a new point. Let us name this new point C. So we want to locate a new point C. The distance AB can be accurately measured in the ground. At the same time, the relative position of A and B can be plotted on the sheet to some scale. Scale means we cannot plot, so let us say distance is 10 meter. So in the sheet we cannot plot 10 meter. So we will use some scale. Scale we are going to discuss in next lecture, so don't worry. So for the understanding purpose I will explain that if we assume a scale of 1 centimeter is equal to 1 meter, so if the ground distance is 10 meter, we will draw in the sheet as 10 centimeter. So again I will repeat, the distance AB can be accurately measured on the ground and the relative position of A and B can be plotted on the sheet to some scale. Thus, point A and B will serve as a reference point for fixing the relative position of other points. Now, the new point which we want to establish, which we have named as C, may be located on the sheet by any of the following direct methods. The first method is distances AC and BC can be measured in the ground and point C can be plotted by swinging arc of length AC from A and BC from B to the same scale that AB has been plotted. So what will happen? These two arcs will intersect and we will able to get the location of point C. This method is shown in this figure. This particular principle is very useful in chain surveying. The second method is a perpendicular CD can be dropped on the reference line AB and length AD and DB are measured in the ground. Now what will happen? When we will be plotting this D point in the sheet, point C can be plotted using a set square. We can see in this figure. The third method is the distance BC and the angle ABC can be measured. So the point C is plotted either by using a protractor or trigonometrically, as we can see in this figure. This principle is used in traversing. Another method will be distances AC and BC are not measured, but angles means two angles. First one is angle CAB at point A and angle CBA at point B are measured with any angle measuring instrument. Knowing the distance AB, point C can be plotted either by using a protractor or by solving triangle ABC. We can see this figure. This figure illustrates this particular method. This particular principle is widely used in triangulation. In the fifth method, angle CBA at point B and distance AC are measured. So, point C can be plotted by projecting an angle at B and swinging an arc at A. We can see this particular method in this figure. Now, the second fundamental principle of surveying, whether plane surveying or geodetic surveying, is to working from whole to part. It is essential to first establish a system of control point and fix them with high precision. Minor control point can then be established using less precise method, and the inner detail can be located using these minor control point by conducting minor traverse. I think this particular theory we will understand in more detail when we will discuss chain surveying. But the basic idea here is that we have to establish the control point with the high precision. Minor control point we can establish with less precise method. This approach helps to prevent the accumulation of errors and allows for the control and localization of minor errors, which otherwise could expand and become uncontrollable if the reverse process is followed. Now we will discuss about various measurements in surveying. During operation of surveying, we take measurement in two planes. One is horizontal plane, other one is vertical plane. In horizontal plane, we can take two measurements. One is horizontal distance, other one is horizontal angle. Similarly, in vertical plane, we can take two measurements. One is vertical distance, other one is vertical angle. So, horizontal distance is distance measured in horizontal plane. And what is horizontal angle? Horizontal angle is angle measured between two lines in the horizontal plane. Theoretically, the angle between two lines can vary from 0 degree to 360 degree. Vertical distance is a distance measured in the direction of gravity, as the direction of gravity is taken as vertical direction. And what is vertical angle? Vertical angle is the angle measured between two lines in the vertical plane. Now we will discuss about the instrument used for various measurement. In today's lecture, we will focus solely on the names and utility of the instrument. In the subsequent lectures, we will explore them more extensively and discuss their function in detail. Okay. So, for horizontal measurement, tape, chain, tachyometer, electronic distance measurement devices are used. For horizontal angle measurement, magnetic compass, theodolite, total station, sextants are used. For vertical distance measurement, tachyometer, leveling instrument like dumpy level, auto level are used. And lastly, for vertical angle measurement, clinometer, theodolite, sextants are used. Now we will discuss classification of surveying under different heads. The first head is classification based on the nature of the field. So, based on nature of the field, survey can be classified as land surveying, marine surveying and astronomical surveying. Let us discuss about land surveying. What is land surveying? Land surveying having many parts. So, this includes topographical survey, cadastral survey and city survey. What is topographical survey? What do you understand by topography? Topography means physical characteristics of an area. Physical characteristics means if in the area any river is there, lake is there, so these are the physical characteristics. So, a topographical surveying is conducted to identify natural features such as rivers, streams, lakes, hills, as well as artificial features like roads, railway, canal, towns and villages. Whereas cadastral surveying focuses on accurately defining property boundaries. And city surveying involves locating urban infrastructure like streets, water supply system, sewers and other amenities. Now we will discuss about marine or hydrographic survey. So, hydrographic survey deals with water body for the purpose such as harbour works, navigation and water supply. Next one is astronomical survey. This method uses observation of heavenly bodies such as fixed star to determine the absolute location of points. Second head of classification is classification based on object of survey. First one is engineering survey. Engineering survey is conducted to obtain the data required for design and construction of engineering works such as road, reservoir, canal, sewage disposal and water supply system. We generally observe people using a dumpy level for surveying in areas where road construction is ongoing. This is an example of engineering survey. Military survey. Military survey is performed to gather a database of points with strategic importance. Mine survey. Mine survey is conducted for exploring mineral wealth. Geological survey. Geological survey is used to gather details about different strata in earth's crust. Archaeological survey, which is performed for uncovering relics of antiquity. Now the third head of classification is classification based on instrument used. So, surveying method can be classified based on instruments or method employed as chain surveying, theodolite surveying, traverse survey, triangulation survey, tachyometric survey, plane table survey, photogrammetric survey, aerial survey. Now we will discuss nature of surveying work. Surveying work involves both field work as well as the office work. Surveyor must also pay attention to the maintenance and adjustment of instrument during their use. So, the work of surveyor may be divided into three distinguished parts. The first one is field work, second one is office work, third one is care and adjustment of instrument. Field work, as name suggests, operation performed in the field. It involves measuring angles and distances, and preparing detailed field notes. There are some key operations performed in the field. What are those? Let us discuss. Establishing reference points and benchmark for horizontal and vertical control. What is the meaning of horizontal and vertical control? Because what will happen when we will do the survey work, we have to establish some benchmark and we have to establish these benchmark frequently, because what will happen during the surveying work, we will be going through a long stretch. So, we cannot all the time rely on the benchmark which we have established earlier. So, we have to keep on updating the benchmark, means after a certain surveying work we have to establish a new temporary benchmark, so that our accuracy of the surveying can be ensured. The very important one is measuring distance, angles and the elevation in the field. Third one is identifying and locating details such as boundaries, road, buildings and natural features. During a field work, a surveyor must prepare field notes in a proper manner to accurately interpret various survey conclusions. Field notes are crucial records made during field work. Field notes should be legible, concise and comprehensive. It should be recorded in a field book immediately as observations are made. It is accompanied by carefully executed sketches. Field notes should have details like survey title, date, weather and equipment used. Correction should be made by crossing out the mistake and recording the correction above that mistake. Okay. There should not be overwriting. If the field notes are not recorded properly, the entire survey work will become ineffective. Now, the second important part is office work. The office work of surveyor includes drafting, computing and designing. Drafting involves preparing plan, section and topographic map. Computing includes plotting measurement and calculating areas and volume. We are going to discuss the calculation of area and volume in the upcoming lecture. Surveyor may also engage in design work, specifically for the route surveying projects. Now, the third task is care and adjustment of instrument. Surveying requires expertise in handling delicate equipment used in both field and office work. Instruments like levels, theodolite and compass require careful maintenance due to their sensitivity. There are some key precautions that should be strictly followed. So, what are those precautions? Let us see. In auto level or dumpy level, telescope is a sensitive part. This instrument auto level and dumpy level we will be discussing in the later on chapter. You will get more understanding about it. Now, you just have an idea about them. What precaution need to be taken? In the auto level or dumpy level, telescope is a sensitive part. So, it should be lifted by the leveling base, not by the telescope. Secure all clamps of the instrument when transporting to prevent the damage. Keep the telescope lenses covered and cleaning should be done with a brush. Never leave instrument unattended in windy or public area. There may be some damage. We should avoid forcing screws. If they do not turn easily, the part should be cleaned and lubricated. Now, we will discuss the last part, which is units of measurement. So, the first one is units of linear measurement. In general, for measuring distance, meters and centimeters are used as units. You can see this table. This provides commonly used basic linear measurement units and their relation both in metric as well as British system. Please go through this table and note it down. So, generally we use these units and also their conversions, like 10 millimeter is equal to 1 centimeter, 10 centimeter is equal to 1 decimeter, 10 decimeter is equal to 1 meter, 10 meter is equal to 1 decameter, 10 decameter is equal to 1 hectometer, 10 hectometer is equal to 1 kilometer, 1852 meters is equal to 1 nautical mile international. Now we will discuss basic units of area. The units of measurement of area are square meters, square decimeter, hectare and square kilometer. I think you can see this table. This table gives units of the area both in metric as well as British system. We generally use these conversions like 10 square millimeter is equal to 1 square centimeter, 10 square centimeter is equal to 1 decimeter, 100 square decimeter is equal to 1 square meter, 100 square meter is equal to 1 square decameter, 100 decameter is equal to 1 hectare and 100 hectare is equal to 1 square kilometer. Now we will discuss basic units of volume. The units of measurement of volumes are cubic decimeter and cubic meters. I think you are able to see this table. This table gives units of measurement of volume both in metric as well as British system. So we generally use this conversions also, like 1000 cubic millimeter is equal to 1 cubic centimeter, 1000 cubic centimeter is equal to 1 cubic decimeter, 1000 cubic decimeter is equal to 1 cubic meter. Now we will discuss basic units of angular measurement. So what is an angle? What do you understand by an angle? An angle is a difference in direction of two intersecting lines. Okay, so when these two lines are there in horizontal plane, it is known as horizontal angle. When these two lines lie in the horizontal plane, the angle is called horizontal angle. When these two lines lie in vertical plane, the angle is called vertical angle. Angle in radian can be expressed by this particular expression: angle is equal to arc by radius. So if we divide arc by the radius, we will get angle in radian. So how can we define 1 radian? So if we are saying that angle is 1 radian, so 1 is equal to arc by radius, means arc will be equal to radius. So for the 1 radian, arc will be equal to radius. So we can define 1 radian as angle between two radii of a circle which cut off on the circumference of an arc equal in length to the radius. For defining full angle of a circle, I think you can see in this particular figure. For defining full angle of a circle in radian, what will be the arc length? Arc length will be the perimeter of the circle. So full angle of the circle will be equal to arc by radius. Arc is perimeter, so it will be perimeter by radius. What is formula of perimeter of the circle? It is 2 pi r. So angle will be 2 pi r divided by r. So angle will become 2 pi radian. From this we understood that full angle of a circle in radian is 2 pi radian. But most surveying instruments are graduated according to sexagesimal system. Let's discuss about sexagesimal system. In sexagesimal system, one circumference is divided in 360 part and the full angle of the circle is also divided in 360 part, and each angle is considered as 1 degree. Then this 1 degree is further divided into 60 minutes and 1 minute is further divided in 60 seconds. So we can see that the full angle in degree will be 360 degree, 1 degree will be 60 minutes, 1 minute will be 60 seconds. So there are two systems we have discussed. One is expressing angle in terms of degree, another one is expressing angles in terms of radians. So can we establish some relationship between radian and degree? Let's try. A full rotation or a complete angle of a circle in the sexagesimal system is 360 degree. In radian system, it is 2 pi radian. So, this is the basis for converting the degree into radian and radian into degree. In other words, an angle at the center of the circle that measures 2 pi in radian will be equal to 360 in degree. So, 2 pi radian will be equal to 360 degree. So, 1 radian will be equal to 360 divided by 2 pi or 180 divided by pi. So, 1 radian will be equal to 180 by pi degree. With this, we conclude today's session. Thank you all for your active participation today. We look forward to discussing the next topic in our upcoming class. Thank you.